the point, line, and polygon. But however, I don't think we need to dig into the detail of that. But there's one probably important line feature extraction method, which is commonly mentioned. That one is called Kenny-H detector. That one is commonly used and also commonly mentioned. Sorry. This one, you can find the algorithm from MATLAB, and you can directly use that to extract a line feature from a certain two-dimensional image. And then, but however, the good thing about this is that it's more robust. It's more robust, and you can. Okay, so let me give you the general introduction about this to this Kenny-H detection. So the procedure of this is it also used the great value gradient to find feature, but however, different, like I said, different line. It could be a line that could be broken into pieces, and so what it does is that it will first find the strong feature, strong H feature, and which means strong or large great value gradient. So they think it is a strong feature. And then there are some weak feature. So for example, why this line were broken into pieces? Because there are some weak feature over there. So if you just use the threshold to identify, so weak feature doesn't mean, it means that it's not a feature, then in this case, it will be gone. It will be broken into pieces. But Kenny-H detector, it gives those weak features a second chance. You can say the second chance. If those weak features they are connected to strong feature, right? If those weak features, weak feature pixels, they are connected to strong feature pixels, then they will be considered as a feature line. They will be considered as a feature line. Okay, so that's the that's the most important thing about the Kenny-H detector. So it gives the weak features a second chance. Okay, so but however, that also makes this algorithm a little bit sensitive to thresholds. It makes it a little bit sensitive to the thresholds. It's kind of like if you have a lot of features and it has two thresholds, and you have some pixels and have strong features, strong, weak. Right. You will set two threshold, T1, T2. Okay, so strong feature will be kept as the feature points. The feature, feature H candidate. And weak features, if it is under the T2 threshold, then they will be gone. They will be considered as not a feature. But whatever in the middle, between T1 and T2, they will be considered as the potential feature line pixels. And then the Kenny-H detector will take a look at these pixels and see if they are connected to the strong features, then they will be included to the feature H or feature line. And if they are not connected, then they will be removed. So what I'm trying to say is that the Kenny-H detector, actually you need to set two thresholds. You need to set two thresholds. Of course, if you are using a MATLAB algorithm, you can also just set one threshold, and the other one is predefined. But however, these two, when you adjust it, as you can imagine, when you adjust it just a little bit, then the whole result could be different. The whole result could be different because it's by using the connectivity to extend those feature lines. Okay, so what I'm trying to say is that Kenny-H detector is commonly used. It's very commonly used. But however, it's sensitive to the threshold that you give it. Okay. Okay. Right. So, but however, there's the other thing. I believe some of you, when you read the paper, preparing the paper that you're going to present, you may find there's one algorithm which is called Hopf transformation, Hopf transform. So that is usually usually processed or usually performed after you're trying to find the feature line or feature line or feature age information, because the answer from the K-edge detector or other feature line extraction method, it still gives you points. It still gives you the points that could be feature line, but it doesn't really give you a line. Right? It doesn't really give you a line like ng define 2 points, 2 endpoints becomes a line. So, but however, K-edge detector gives you those pixels that could be one feature line. Okay? So how to generalize, you can say, how to generalize a line from those pixels, it needs another process. And sometimes it's called Hopf transform. I forgot how to spell it, so just H-O-F-F. I forgot. So do I have that here? 1 sec. No, I don't have that here. So, I'm sorry, I forgot how to spell it. But however, it's called Hopf transform. It's a name. It's a name. Okay. So, it's a person's name. So it's named after a person. So that's what I'm trying to say. So that's the case. The feature polygon extraction is usually by performing, for example, like segmentation or region growing. So I believe it's a general like image processing method. So you guys should already know that. And feature point extraction methods, there are lots of feature point extraction methods. So you can just take a look at the lecture slides, and then you can get some idea about that. And the SIFT that the first presenter present yesterday in the seminar, the SIFT, S-I-F-T. If you guys still remember. Yeah. If I remember it correctly, SIFT is actually scale invariant feature transformations, I believe. Is that it? Okay, yeah, scale invariant feature transformation. So yesterday I was asking him about, say, what's the good thing about SIFT. Actually, the name tells it. The name already tells you that it's scale invariant. It's finding the feature that is invariant to scale. So you can have different scale, you can have the scale differences between 2 images. But however, the SIFT algorithm can help you to find the matched point between them. Why? Because it has the process to produce from a raw image and produce the images, and you can say like smooth, but by performing the Gaussian kernel and on the raw image to produce different scale, different images, the images with different scale, like kind of simulate the image in different scale, and then you have that 3-dimensional cube, and then inside that 3-dimensional cube, try to identify the feature points, and that is the that's why it becomes scale invariant. Okay, so that's the reason, and actually the name tells it. So yeah, unfortunately, he didn't give us the clear answer yesterday. So we will see. But some of you, I believe some of you, when you are reading the paper that you're going to present, some of the paper they use SIFT and also structure from motion. Structure from motion also use SIFT as well. Okay, so you guys will hear that and will learn that. We'll kind of learn that. Okay. Okay. Any question regarding everything that we mentioned? That's pretty much wrap up all the image matching related discussion. Okay, so I'm not image matching is actually very you can say it has been around. This type of topic has been around for more than 40 and 50 years. So it has been a topic in algorithm for a long time. So there are a lot of things to be discussed over here. But however, I think it should be enough already. Those information I give you guys should be enough for you to have some basic idea. And then, of course, there are some advanced solutions, and that's, well, what we can learn from the paper presentation. Okay? And if in the future you need those information, at least you know the basic ideas. Okay, okay, any question? All right, if not, then we will move on to the next topic, which